So you write this out like a regular long division problem. Okay. 10n cubed going into n to the fourth plus 4n cubed plus 2n squared. Now this is an interesting one because you're going to end up with like a fraction. So how many times does 10 go into 1? 10 goes into 1 0 times, right? Oh, this is a tough one to do. So we could say 1/10 up here, right? 1/10 times n or whatever. I don't know. Let's just do the 0 times and I'll show you. It still works out. So technically then, wouldn't all of this be the remainder? Yeah? Does that make sense? All of this would be the remainder because 0 times this would be 0. And so then our remainder would be n to the fourth plus 4n to the third plus 2n squared. Well, what do we do with the remainder? We put the remainder on top of the divisor. So what we would do is we would have n to the fourth plus 4n cubed plus 2n all over 10n to the third. So I want you to think about this. Let's say I have 2 plus 4 all over 5. What would the answer to that be? 6 over 5, right? But what if I were to say 2 over 5 plus 4 over 5? What would the answer be? Still 6 over 5. So we're going to work backwards. We're going to take this and rewrite it as n to the fourth all over 10n cubed plus 4n cubed all over 10n cubed plus 2n all over 10n cubed. So that's technically our answer, but we've got to reduce each fraction. We have to write the fractions in the simplest form. Was it 2n squared? You're right. Cool. So now, I want us to think about this for a second. If I say n to the fourth over n to the third, technically this is n times n times n times n 4 times, right? And technically this is n times n times n 3 times, right? Well, what's n divided by n? 1. So this reduces down to 1 over 1. This n over this n would reduce down to 1 over 1. Now, a lot of your middle school teachers would say they cancel, which is kind of true, but I want you to know mathematically they reduce down to 1. So 4 on the top reduced down with 3 on the bottom, and you're left with just 1n on the top over 1, right? Because 1 times 1 times 1 times n is n. 1 times 1 times 1 is 1. Anything over 1 is itself. So this really is 1n over 10. Now, a shortcut way to do that is I could say, well, I can subtract 3 from the bottom, subtract 3 from the top. That gives me my n to the first on top. Okay? That's a shortcut way to do it. Now, on the next problem, what is 4 over 10 reduced down to? Think of a number that divides evenly into 4 and also divides evenly into 10. Yeah, 2 does. What's 4 divided by 2? 2. What's 10 divided by 2? 5. So that reduces down to 2 over 5. Now over here, usually you would choose the lowest power, and that's the one you would subtract. So, but they're the same. So if I subtract 3 here and I subtract 3 here, doesn't this become n to the 0 and this becomes n to the 0? What's n to the 0 equal? Anything raised to the 0 power equals 1. So that just really stays 2/5 times 1, which is 2/5. Does that make sense? Now on this next one, the shortcut is the same thing. We're just going to subtract 2 because 2 is the smallest power, right? And whatever I do on the top, I have to do to the bottom. Also, we have to reduce the 2 over 10. What does 2 over 10 reduce down to?
1 over 5.
1 over 5. Now, what is this right here? This is 2 minus 2, which is n to the 0, which is 1. But what's this here? 3 minus 2, n to the 1. So I have an n on the bottom here. That's our answer. It's a little wonky, but that's what it is. Any questions on that? Now, how do you feel about that one? I promise we'll have an easier one on the test. Sometimes I like to put a little bit harder problems on the practice tests because if you can figure out and understand those questions when you get the real test, it's a little easier. Okay. Well, that concludes problem number 9.